Okay, so we want to continue the lesson, but before that, I think it is better to give you some exercises and wait for you a little bit so that you can work on it. And then I solve them so that if there is some problems left, they can be solved. And then we can go to the new lesson, which is a very important one, squaring and conjugate patterns. It's simple, but very important in algebra. Okay, so let me start with an example. I write the example. As soon as I wrote the first part, don't wait for me. You start solving them. I will continue more, and then we come and solve the problems together. So example. And please, if you have any questions, just talk to me. I cannot see the chat window. Expand. And of course, simplify. Yeah, so as soon as I wrote the first one, you start solving it, okay? So number one, x plus 2 times 3x squared minus 1 minus 2x minus 1 times 3x plus 2. I want you to do this multiplication and be careful about negative signs and everything, and then simplify this expression. So you start, I will continue writing. Okay, so let me start solving the problems one by one, and then you can compare your solutions to mine. And if you have serious problems, please let me know. Miscalculation is actually here, the calculation is very important. So it is not a hard problem, so you need to increase your skills in computation as well. Okay, so here, number one, I want to expand this expression. So here, this is the product between these two. That is also a product between these two. And then I have subtraction and addition, but we know the priority is with multiplication, yes? So this means that I don't do anything with the first term x yet, but I know that I can multiply these two, okay? So, of course, let me do it step by step. In principle, you can immediately remove the pair of brackets, but let me keep it for the time being. So what I am doing, I am actually calculating this bit. How? By multiplying 2 inside. So then this becomes 6x squared minus 2. And then I go to the next one. There is a difference here, but the priority is with this product. So I keep this negative sign with a pair of brackets and I do this multiplication, yes? So this becomes negative. And then I will start doing this multiplication as we learned yesterday. So this multiplied here, multiplied there, and then when it is finished, I will go and take minus 1, multiplied here, multiplied there, yes? So if I do that, then it becomes 6x squared plus 4x minus 3x and minus 2, yes? So if you multiply this by this, it gives me 6x squared. If you multiply this by the next one, it gives me positive 4x. And then if I multiply minus 1 by 3x, it gives me minus 3x. and minus 1 times 2, positive 2, it becomes negative 2 at the end. Okay, so you can simplify this here and then apply this negative sign here. So let me just do it here. For this one, I can only simplify these two, yes? Because these are the only similar terms. So 4x minus 3x is just simply x. And then I try to remove the pair of brackets because I told you when I say expand, it means write your expression in which there is no pair of brackets left. So this is not finished yet because I see that I have a pair of brackets here, a pair of brackets here. Okay, so how should I do that? I continue here. It becomes x. When I want to remove this pair of brackets, there is no problem because there is a positive sign behind that. Positive sign actually means positive 1, and if you multiply positive 1 here and there, nothing will change. So it becomes positive 6x squared, negative 2. But then be careful about this negative sign behind the pair of brackets. This is what you need to keep in your mind all the time. So this minus sign is actually minus 1, you can interpret it. So when you multiply it, it not only multiplies here, but also here and there, yes? So it means that whatever is negative, it turns into a positive term, and whatever is a positive, it turns into a negative term. So 6x squared is positive, but after this minus sign is applied, it becomes negative 6x squared. This x is positive 1x, yes, because the difference between these two is positive x. And when I multiply it by negative sign, it becomes negative x. And then finally, this negative sign will be multiplied here. It turns out to be positive, to a positive 2. But can I simplify more? Yes, I can simplify more, and that's very interesting here because this x and that x are similar and opposite, so they are cancelled out. And this 6x squared and this 6x squared are also cancelled out, and this minus 2 and minus 2 are also cancelled out. So this kind of cancellation, what is left? When I say that x and minus x are cancelled, it means that minus x is 0. When I say that 6x squared and minus 6x squared are cancelled, it is 0. Because sometimes you see, when I use the word cancel here as well. Here I say that x and x are cancelled, but here I am dividing. So the answer is not 0, the answer is 1. Because here I am using the word cancelling from the numerator and denominator. In that case, the answer is not 0, the answer is 1. But when I say cancel, I'm subtracting them. Of course, the answer is 0. Okay, so I have this, so the final answer is 0. So it is interesting. So it doesn't matter what value for x you use here. If you take a value of x and calculate this expression for that value, regardless of the value, it becomes 0. Yes. So if you have any questions, please, because I see there is chat, I cannot see the chat window. If you have questions, please talk to me, okay? Any questions? So I hope that most of you, all of you actually, was able to get the correct answer. So the correct answer for number 1 is 0. Now I go to number 2. So number 2. Again, you see here, I have a product here, I have a product here, I have a product here, and then I have subtraction. So this means that I have to give the priority to these multiplications, yes? Okay, so what can I do here if I want to write everything? So let me put the equality here as well. So here, I multiply this 5b here and here. So what happens? Let me keep the pair of brackets for the time being. So it becomes 5ba minus 5b squared minus, but here I have 3 expressions multiplied. One of them is 3, one of them is a minus b, the other one is a. So I need to do it step by step. So of course you can do it quickly, and if that is
Babak, you
correct.
skipped number 2. You're solving number 3 right now.
Oh, sorry. Thank you very much. Thank you very much. So let me go to number 2. Yes. Thank you. So number 2 is I have a product of 3 pair of brackets. So if I want to do that, what should I do? I need to multiply 2 of them first, and when I got the answer, I multiply the answer to the third one. So that is the strategy, yes? So this becomes equal to, here I take 2a and multiply it here, here, and there. And when it is finished, I take minus b, multiply it here, here, and here. But then I have to keep this one intact, yes? So I would say that I open a pair of brackets, 2a times 4a squared, it becomes 8a cubed. 2a times 2ab becomes 4a squared b. And then 2a times b squared becomes 2ab squared, yes? So these 3 terms that you see here are the results of the product of this here, here, and here. Now that this is finished, I go to minus b and multiply it here, here, and here. So the answers would be minus 4ba squared minus 2ab squared, and then minus b cubed. But you shouldn't be in a hurry. I don't want to touch this part. It means that I have to rewrite it. Okay? 8, a to the 3, b to the 3. Okay, but this, I can simplify this. After I simplify that, I will start multiplying the next one. How can I simplify this? So let me find the similar terms. So if you see this one and this one are similar, yes, because the latter part is a squared b, here is also a squared b, even though it is written ba squared, but there is no difference. But the good point is that they are similar, but with opposite terms, so they are cancelled. And then the same story here. So if you see this one is also similar to this one, and opposite, okay, so it means that this is also simply cancelled out. So from the whole expression here, only 2 terms survive. One of them is this one, the other one is this one. So let me just repeat it. So this becomes 8, a to the 3 minus b to the 3, and then you multiply it by 8a to the 3 plus b to the 3. Now I start multiplying this again. So I have to multiply 8a to the 3 here and here, and then I will multiply minus b here and here. So the first term is 64, a to the 6. The next one is plus 8, a to the 3, b to the 3. And the next one is minus 8, b to the 3, a to the 3. And finally, minus b to the 6. But this is not finished because still I can simplify these 2 terms. One of them is here and the other one here. They are similar. And again, they are not only similar, but they are exactly opposite to each other. So they will cancel out. So what is left for me is just 64 a to the 6 minus b to the 6. Okay? I hope that you got the correct answer for this one as well. So these are a little bit higher level questions, but this is not very, very hard, but you need to be very good in these kind of calculations. Okay, so now let us go. Yes?
Is this A level or C level?
I cannot actually judge it that much. I wouldn't say this is A level. So because there is no creativity here, you know? Yeah, I would consider between something between C level and A level, okay?
Yep.
Okay, so here number 3 now. So here I have 3 terms, this is written in the form of a product. This is also a product. This is also a product. So the priority is with these products. So I have to multiply them. Yes. Okay. So here, what I should do, let me write it patiently again. So I will write this. I will multiply 5b inside. So this becomes, let me keep the pair of brackets. As I told you, you really don't need to write all the details. But when I am teaching, I prefer to write all the details so that I make sure that you understand everything properly. But in the exam, if you just do it quickly, and that is okay, that's correct, that's okay with me. Okay, so I would say that I multiply 5b inside, so it becomes 5ba minus 5b squared, yes? But here I have 3 terms involved. So let me keep this negative sign, let me multiply 3 here first. So this becomes minus 3a minus 3b. Of course, you can multiply it immediately together. And here I have a 3. Let me multiply it here and here. Yes? Okay, so I will have minus. I open a pair of brackets, so it becomes 3a squared. But let me do this in my head. I'm supposed to multiply 3 here. So I have to multiply 3 by 5 over 3. Of course, this 3 and this 3 will be canceled. I am left with 5. But the sign is negative, so it becomes minus 5b squared. Okay? But now I can remove the first pair of brackets, so it becomes 5ba. There is no sign behind it. It means that that's positive. I don't have any problem there. But there is another product left here, so I have to multiply this as well. So I have to multiply a here and here. So let me do it in 2 steps. I keep the negative sign. I open the pair of brackets. I multiply a inside. It becomes this. And then let me keep all the pair of brackets and then remove all of them together. As I told you, you really don't need to write all these details. Okay, now I start removing the pair of brackets. I don't need to be very careful here. I just remove the pair of brackets because there is no sign behind that. It means that that's positive. So this becomes 5ba minus 5b squared. But for the next one, I have to be careful. When I open the pair of brackets, this minus sign not only goes for the first one, but also for the second one. So then it becomes minus 3a squared, but the other one becomes positive 3ba. And the same is true for the next one. It becomes minus 3a squared, but positive. This I have seen students sometimes forget to multiply the negative sign to the other terms. So you need to be careful in that regard as well. Okay, now I need to find the similar terms. So is there any term similar to 5ba? So yes, this one and this one are similar. So these two are similar. And these two are also similar. And these two are also similar, yes? Okay, so if you see here, I have 5ba plus 3ba, so it becomes 8ba. And then the next one, they are similar, but they are opposite as well. So they are completely gone. And then here I have minus 3a squared, again minus 3a squared. So it becomes minus 6a squared.
But could you scroll up to the question again?
Yes.
Where did 5/3 go?
So I told you that when I multiply this 3 here, so this multiple 3 times 5/3, this 3 and this 3 are gone.
Right.
It becomes
Okay.
5. Yes.
Okay.
Okay. So hopefully you were able to get this answer right. So let us go to number 4. So number 4, let me do it speed up a little bit. So number 4 here, what I see, I have a subtraction here, but I have a product here. The priority is with the product, so I have to keep x to the 7 and then start multiplying these. But because this is the product of 3 expressions, I need to do them one by one. So I will multiply this here, meaning that I will take this one, multiply it here and here, but that I will keep this one and I will do that one later. So this becomes minus x to the 3 plus x to the 2, and then I will copy and paste the rest of it. And then what I need to do, again, I have a product here, so the priority is with this product, not with this subtraction, this difference, yes? So what I do is x to the 7, I keep this one and I start multiplying this here, here, and here, and then I will take this, multiply it here, here, and here. So then it becomes x to the 7 minus x to the 6 plus x to the 5. And then I have x to the 6 again, minus x to the 5 plus x to the 4. Yes, let me explain. When I multiply this by that, x to the 3 times x to the 4, it becomes x to the 3 plus 4, it becomes x to the 7. This is the reason that I have written x to the 7. For the same reason, if I multiply this by that, it becomes negative x6. If I multiply this by that, it becomes positive x5. And I did the same things for these 3, and I got these answers. But before opening the pair of brackets, you see that I can simplify. This minus x and this x to the 6 and this one are similar. These are also similar. But fortunately, they are not only similar, but they are also opposite. So I can cancel them out. And this I also cancel them out. So what is left for me? So let me rewrite it again to make it clear. So it becomes x7 minus x7 plus x to the 4. And then what I need to do, I need to open the pair of brackets. When I open the pair of brackets, because behind that there is a negative sign, it goes not only for the first one, but also for the second one as well. So it becomes minus x to the 7 minus x to the 4. But then again, I realize that these two are similar and opposite, so they are canceled. So what is left for me is negative x to the 4. So that is the simplified version of what we have here. Hopefully you were able to get the correct answer. And now we go to the last one. So the last one, there is nothing tricky here. It's as before. So here I have a product. Here I have a product. The priority is with the product. Okay, so hopefully I can fit this. Let me make it a little bit smaller here. So number 5. So what I need to do, I will keep the first term and I will start multiplying, for example, 2 inside. So I will keep this minus sign. I multiply 2 inside, it becomes 2x minus 4. Then I copy and paste the next one. Okay, for this one, I can multiply minus 2 inside, so it becomes minus 2x plus 2. And then I will have 2x squared minus 4. And then here I will write 2x to the 3. I open a pair of brackets and I multiply these two. So be careful, because there is a negative sign. It is important. If you want to do it quickly in your head, you need to consider that this minus sign goes for all the terms. I recommend for the first time, or at least for the first few times, try to write everything properly. Then when you get used to it, you can do it quickly in your head. Okay, so I will multiply this by that, as usual. So it becomes 2x cubed plus 4x squared plus 8x, and then minus 4x squared minus 8x minus 16. And then I have minus 2x plus 2 plus 2x squared minus 4. Finally, I can remove the pair of brackets. It becomes, of course, you can simplify first. It is better. So here I have this one and this one are similar and they are gone. And then I have this one and this one. They are also similar, by the way. They are also gone. So let us get rid of them. And then 2 terms survive. One of them is here, one of them is here, but this negative sign goes for this and that. Yes, so it becomes it goes minus 2x cubed plus 16, and then I will copy paste the rest of it. Okay, so then I have similar terms again. Yes, here this one and this one are not only similar but opposite, so they are totally gone. I don't see any other similar terms except these numbers, so let me write it in this way. So let me write 2x squared first, then I have minus 2x, then I have some numbers left. Minus 4 plus 2 is minus 2, plus 16 is positive 14. So plus 14, and this cannot be simplified more. Yes? So this is a recap of what we have learned in the previous session. Of course, these exercises are a little bit harder. So any questions so far?
No.
Okay, good. So now I want to go here and talk about today's lesson, which starts on page 10 in the book. So I will teach 2 pages 10 and 11, and then you can work on the exercises on page 11 and 12. Okay, so squaring and conjugate patterns, this is a very simple lesson, but extremely important. Okay, sometimes there are some patterns that they repeat itself over and over again in mathematics in different branches. Okay, so it is worthy that we learn that pattern and find the formula for that pattern so that we can use it whenever it occurs when we are solving a math problem. Okay, so let me write this a squaring rule first. So squaring pattern. There are many times in mathematics that there is a sum of 2 numbers and you want to square it. So for example, of course, if I give you 2 plus 3 to power 2, you really don't need to know this pattern to be able to answer my question, because you immediately say that, okay, 2 plus 3 is 5, and 5 to power 2 is 25. That's of course correct. But if I have algebraic expressions like a plus b to power 2, if I ask you to remove the pair of brackets, first of all, you cannot write a squared plus b squared. If you write something like this, let me write it and cross it over. This is not the correct answer. I think the main source of this common mistake is people confuse themselves with this rule, which is correct. If I have a product and I want to raise it to power 2, if I want to remove the pair of brackets, I can simply write a squared times b squared without any pair of brackets. This is true. Yes, but this one is not true. And if I ask you here, if I ask you remove the pair of brackets, you don't have any problems, because you add 2 and 3, it becomes 5, and then you raise it to power 2, it becomes 25. If I ask you the same question for this pattern, if I ask you remove the pair of brackets here, of course, the answer is not this. By the way, you can convince yourself the answer is not this. If I raise 2 to power 2, it becomes 4. If I raise 3 to power 2, it becomes 9. If I add them, the answer becomes 13, but you know that the correct answer is 25. So make sure that you understand that this is not working. So can you tell me, how can I remove the pair of brackets?
Well, you can just write it as a plus b times a plus b in brackets, and then you multiply it.
Exactly. So this is the only way that we can do it. So it becomes a plus b, and then I multiply it, so it becomes a squared plus ab plus ba plus b squared. Then I get 2 similar terms. I add them, so it becomes a squared plus 2ab plus b squared. This is called squaring pattern. So this is something that I want you to memorize, even though you will have this formula over and over again in the formula sheet. But this is so important that I urge you to memorize it, but not just memorize it, to understand what is how you should read the formula. So this is called a squaring pattern. Okay, so let me see that if I can put it in a proper box. Yes, so that is called squaring pattern. But I just don't want you to blindly memorize that. So this tells you that if you have the sum of two terms and your intention is to square it, you take the first one and square it. You need to multiply 2 by the first one by the second one and add it here. And then you go and square the second one. So this way of interpreting this formula is important. Whenever you have the sum of two terms to power 2, if you want to expand it, a squaring rule or a squaring pattern tells you to do this in this way. Take the first one, square it, multiply 2 by the first one by the second one, and then finally square the last one. This would be the answer to your problem. For example, of course, it is very important to know that in the exam, when I say use a squaring pattern to expand the following expressions, if you use multiplication, definitely you will get the correct answer, okay? But this you will lose the points because I have mentioned use this pattern, because the emphasis here is to show me that you know how to use the squaring pattern. Okay, so when I emphasize the word use a squaring pattern to expand the following expressions, you have to use the squaring pattern. If you use multiplication, definitely you will get the correct answer, but that is not acceptable for that particular question, because in the question it is mentioned that you have to use a squaring pattern. Okay, so for example, if I give you an example here immediately, can I use a squaring pattern for this expression? I have 2x plus 3y squared. Can I use a squaring pattern for this, for expanding this expression? Let me repeat. Yes, the answer is yes. Why? Because I have two expressions added, and my goal is to square it. Whenever I have the sum of two terms and I want to square it, you need to remind yourself about the squaring pattern. But you need not blindly memorize that. You need to be able to read this formula, for example, in Swedish or in English or any language. This tells you that if you want to expand this, take the first one. Which one is the first one? This one is the first one. Take the first one and square it. And then plus 2 times the first one. So I don't need to put brackets. All of them are products. So multiply it by the second one. Yes. So here, this one is the first one. This one is the second one. The first one to the power of 2. 2 times the first one times the second one plus the second one to power 2. Okay, so I have seen some mistakes like this. If you write this, it is wrong, yes? Because the whole expression, the first, if I ask you what is the first one, you don't say x, you say 2x is the first one. So when I say the first one to power 2, I mean the whole first one to power 2. So it is important to write these pair of brackets. If you write just 2x squared, these two expressions are not the same. Yes? Okay, but now look here. What is the operation between 2 and x? The operation between 2 and x is a product, and I want to raise it to power 2. This one is true when it comes to products. So it means that I can write the first one to the 2 multiplied by the second one to the 2. But nobody writes it in this complicated form. 2 to the 2 is 4, x to the 2 is x squared, so this becomes 4x squared. So you see, this problem is not finished yet because I have pair of brackets left. When I say expand, there shouldn't be any pair of brackets. So I will continue. Instead of the first one, I write 4x squared. What can I write here in the middle? Yes, 2 times 2 times 3 is 12. And then I have x times y. I am multiplying everything, yes? So this becomes 12xy. And then finally, for the same reason as I explained here, the last one becomes 9y squared. So if I ask you to use a squaring pattern to solve this problem, I expect you to be able to write that. And I think it is better not to get used to writing this middle one. So if you just know immediately this answer is correct, you can just write that. But you see, if you just raise this one to power 2 and the second one to power 2, you see, if you get this answer, this is not the correct answer. Of course, in the correct answer, this exists. This also exists. But there is an extra term that you will miss if you just do it like this. So be careful about that. So that is the idea of a squaring pattern. So I will solve it 1 or 2 more problems, and then I go to conjugate pattern, and I will continue it a little bit on Friday, okay? Any questions, more or less here? Okay, so let me give you, yeah, good. So let me give you another example. Yeah, thank you. Let me give another example here. So what can I do with, I don't know, for example, 2a squared b plus 3b squared, and I want to raise it to power 2. Again, you need to know when to use it, okay? Of course, here I am teaching a squaring pattern, and then probably you know that I am talking about a squaring pattern, so any example that I am giving now is related to this pattern. This is not good. I want you to understand that when you can use this pattern can be used if what you are doing is you have 2 terms added together and you want to square it. Whenever this idea, whenever this structure happens in your calculation, you can always use a squaring pattern if you want to. Okay, but then what is my first term? The whole expression here you see is my first term, and the whole expression here that you see is my second term. And then I need to read it in English. This tells me that take the first one and square it, multiply 2 by the first one by the second one, and then take the second one and square it and add all these 3 together. So let me just write the intermediate step. The first one, square it. I will take the first one, which is this expression, and square it. Then I will write 2 times the first one times the second one. And then I will write plus the second one squared. This you can do it in your head if you want to. But for the time being, let me write everything. But this is not finished, because when I say expand, it means to remove all pair of brackets. I am 2 pair of brackets left yet. But this is a product. I know for product, if I have a product of a bunch of terms and I want to square it, I can do them separately, individually. But let me write it here to make sure that you understand everything. So here I have this. I want to square it. Because the operation is a product, so I can square the first one, I can square the second one, I can square the third one. But the squaring 2 means 4. You remember there is a rule for this. If I have a to power m, again to power n, I am allowed to multiply the exponents. So here it becomes a to the 4, and then I have b to the 2. So I expect you to be you can immediately write this. So the first one is 4a4 b2, yes? So it becomes 4a to the 4 b2. And here, everything is a product. So it's better to multiply numbers together. So it becomes 2 times 2 times 3, which is 12. And then here, a squared is alone. There is nothing a here, so a squared is alone. But then I can write b multiplied by b squared. It becomes b to power 1 plus 2, which is b to the 3, yes? So then it becomes b to the 3. And for the same reason, the next one becomes 9 b to the 4. And this is the final answer to this problem. Is that okay?
Yes.
Good. But in the book, a squaring pattern is written in two different ways. In two forms. One of them is with positive sign in between. The other one is negative sign in between. So let us see what happens if I have negative sign in between. How can I answer this? So if assume that this, the difference of two expressions is given to you, and your goal is to expand this without having any pair of brackets at the end. Okay, we can do it in two different ways. Either, as Rocco said, I can write it twice because still I don't know the rule. This is important, by the way. You see, I know the rule only for positive. So this is different from this one. So if I ask you what is the rule for the difference, you start from scratch again. I multiply this twice, I start multiplying this, it becomes a squared minus ab minus ba plus b squared. But then these two are similar, so but they have negative signs, so it becomes a squared minus 2ab plus b squared. Yes. So if I write this squaring pattern version 1, I am referring to this is positive, okay? But now you see that if I have negative in between, nothing changes here. This is exactly the same. Nothing changes here. That's exactly the same. The expression here is also the same, but this minus sign appears actually only here. So the only effect of this negative sign is that you see it here. Okay? So let me write this and keep it somewhere. So these formulas are given to you. So a minus b squared is a squared minus 2ab plus b squared. And this is also squaring pattern. I would call it version 2, yes, for example. Okay. So this is useful if I have the sum of two terms, I want to square it. This is useful if I have the difference of two terms, I want to square it. This is also, I think, instructive if you see, how can I use the version 1 to conclude version 2? I didn't do this in this way of proving. I just multiplied them, but I can do that, yes. If I want to do another way, so let me write it with a different color. Every difference can be viewed as a sum. Can you tell me how? How can I see this difference as a sum?
Plus the negative version of the thing you're subtracting.
Exactly. So this becomes, instead of a minus b, I can write a plus minus b. I hope that every one of you agree that this is exactly the same expression. So this equality is valid. But now, can I use a squaring pattern version 1 for this?
Yes.
Yes. But if I ask you, what is the first term, you would say a. What is the second one? You would say negative b is my second term. So then I use the squaring pattern version 1. I would say the first one to the 2 plus 2 times the first one times the second one plus the second one to the 2. A squared is just a squared. But if I ask you, if I multiply them here, what will happen? You would say that 2 times this negative sign, it becomes negative 2. And then a times b is just ab. But even though this is minus b to power 2, minus b to power 2 means minus b times minus b, but it becomes again positive b squared. So this becomes positive b squared. So it means that for this one, I can show it in two different ways. Either I can start from scratch again, or I can reduce this problem into a problem of a squaring pattern version 1, and then I use that version to prove this formula again. Okay, but anyway, the book has written it in two different ways, so this is why I put them here. So if I have a positive sign here, the only effect of that positive sign is here. The only effect of this negative sign is here. That's okay. Let me just give you another example, and then we go to the next pattern. Okay, that is also very simple. For example, I give you this. Let me write 2x to the 3, y to the 5, minus 3x to the xy squared to the 2. So if I want to expand this using the squaring pattern, I have to use the version 2 of this, yes, because I have the subtraction, I have the difference between two terms, and I want to square it. Okay, so what should I write? I should square the first one, and then because this sign is negative, I should write -2 times the first one times the second one. So here, this is my first term, this is my second term. I am using the second version, so I take care of the negative sign here. And then finally, I will have the second one to the 2. But then hopefully you can immediately answer this. The answer to the first one, can you tell me what is the answer to the first one to make sure that you know it? What is the answer?
I think it is 4x to the 6 and y to the 10.
Exactly. Thank you very much. So if there is a question, please let me know if you don't understand that. So this is the answer. But then here I have 2 times 2 times 3 is again 12. I have a negative sign, it becomes -12. And then I have x to the 3 here, another x here. If I multiply, because I'm multiplying them, it becomes x to the 4. So this is x to the 4. Then I have y to the 5 here, y to the 2 here. If I multiply them, it becomes y to the 7. So this becomes y to the 7. And then the next one, hopefully you understand that this is 9, x to the 2, but y to the 4. Okay, so that is a squaring pattern. What is conjugate pattern? Many times in mathematics, this pattern arises actually. So we will have this situation. I have two numbers or two terms once added, the same two terms subtracted, and I am interested in multiplying this combination. You will see as we proceed in mathematics, you will see that many times we have to expand a product like this. Or of course the other way around, a minus b, a plus b. So how should I understand this pattern? I have two numbers, two terms, once added, once subtracted, and then I am interested in the product of this combination. The answer to this, let us calculate this. You don't need any extra knowledge to be able to answer this because that is just a simple product. Let us do this from scratch. So a times a is a squared, a times minus b is minus ab, b times a is positive ba, and b times minus b is minus b squared. Yes? And then you immediately see that these two terms are not only similar but opposite, so they are canceled out. So what is left for me is just a squared minus b squared. That's it. That is called the conjugate pattern. Okay. These two expressions are called conjugate of each other. If I have two numbers added, two numbers subtracted, This is called the conjugate of this. This is called the conjugate of this. Okay, conjugate with this spelling. And I think it's in Swedish is also conjugate, but you just have conjugate, probably you will say, but then this is K, yes? Anyway, let me write this here. So A plus B times A minus B is A squared minus B squared conjugate pattern. Of course, it doesn't matter. If you want, you can write it the other way around, because there is no difference between A minus B times A plus B or the other way around. Both of them, the answers are the same. I don't call them version 1 and version 2 because they are actually the same.
What about B minus A though?
No, that would be different. So you need to be careful. Let me get rid of this, and then I will explain that. So for example, what you are asking is that if I have B plus A minus B, there is no difference between B plus A and A plus B. So the answer is again A squared minus B squared.
No,
But if I have B minus A plus B, this is you need to be careful. Yes? Okay, that's a good question. If I have B minus A times A plus B, how should I know that which one is the first one, which one is the second one? Let me tell you. Here, I cannot, of course, if I want to read it from left to right, A is the first one, B is the second one. But there is no difference between A plus B and B plus A. So there is no this is not a lie if I say B is the first one, A is the second one. Okay, so this pattern is not sensitive to this one, which you see the sum. It is sensitive to this one, which you see the difference. Here, if I ask you in A minus B, which one is the first one, the answer is definitely A, not B. Okay? Because A minus B and B minus A are different. So the conjugate pattern is sensitive to that one, including the minus sign. So whatever is coming first in the one with negative sign should be also written first in the answer. Whatever is coming second in the negative one should also come as the second term. So for example, let me write this with green. If I have this situation, so what is the answer? First of all, is it a conjugate rule? I would say yes, because I have two numbers, once subtracted, once added, and I am interested in the product. So everything is according to the conjugate pattern. But if you are careless and write A squared minus B squared is wrong. Because I told you that when you want to write the answer, you need to look at the one with negative sign. If B is first, you need to write B squared first. And if A is the second, you need to write A squared the second and put the negative sign here. Could I answer you, Rocco? Hello?
oh, sorry. Okay, so if it's A plus B times B minus A.
A plus B times B minus A, yes?
Yes.
So the answer is B squared minus A squared.
Okay. So it's just the opposite.
Yeah.
Okay.
Because the reason is that I told you, first of all, you need to realize this is a conjugate pattern. Is it a conjugate pattern? Yes, because I have two numbers involved, are A and B. Once they are added here, once they are subtracted, and then I am multiplying them. So the pattern is complete. It's a conjugate pattern. But when I want to write the answer, I need to write one of them to power 2 minus the second one to power 2. But which one is the first one? Which one is the second one? I look at the pair of brackets, including the negative sign. If B is the first one there, I need to write B squared first and then A squared. Is that clear?
Yes, I understand now.
Okay, so that's good. So let me write this here. The answer is b squared minus a squared. So let me also write this one here if you want to. So what was that example? So this is a plus b, as you said, b minus a. So the answer to this one is also a b squared minus a squared. Okay, so there is just one small time left, so 3 minutes we have. So let me give you some examples. Okay, so can I use the conjugate rule, conjugate pattern for this? Can I use the conjugate pattern for this? You need to repeat this for yourself, okay? Of course, the lesson is about conjugate pattern. You know that my examples are related to conjugate pattern, but later you need to discover it yourself. You need to discover the pattern yourself. How? I would say to myself that I have two terms involved, 2x and 3y. Once subtracted, the same two terms are added again, but and I am interested in multiplying this combination. Yes? So this means that yes, this is the conjugate pattern. So I need to put a negative sign here. I need to write something to power 2 here, something to power 2 here. But which one should come first? I go to the one which includes the negative sign. Which one is coming first? 2x is coming first. So this means that I need to write 2x to power 2, and then I need to write 3y to power 2. But still, I have pair of brackets left. I need to continue. But I don't need any pattern here. I know that a times b squared is a squared b squared if I have a product. And this is a product. So the answer becomes 4x squared. If you stop here, it's not complete. You need to continue. And then 9y squared. One more important thing that I want to mention is that this power of 2 here is not affecting this negative sign. You see, this b square, this square here is only for b. It is not minus b to power 2. It is b to power 2 minus. This is not positive b squared, be careful. So the answer of the conjugate pattern, the sign between is always negative. Okay, let me give you one more example and then we are done. So I can choose one example from the book. So this is the example in the book. 5z plus 1 times 5z minus 1. Can I use the conjugate pattern here? The answer is yes, because I have two numbers, two terms, 5z and 1. Once added, once subtracted, and then I want to multiply them. So the answer is the first one to power 2, the second one to power 2, and then negative sign in between. How should I realize one is the second one? I don't look here, I look here. One is coming in the second place here when the sign is negative. And then if I continue, the answer is 25z squared minus 1 to power 2 is just simply 1. So I don't need to write. So that's the answer. Okay, so what I covered is page 10 and 11. The exercises are on page 11 and 12. I really recommend you to try to do as many problems as you can. But of course, next time on Friday, I will complete this discussion. I want to go a little bit beyond the book to see that how you can use this more effectively for solving harder problems, okay? So on Friday, I will not go forward. I will complete what I have done. It's a short session, but we will complete it here. Okay, so let me stop this video.